So I'm going to explain the longest common subsequence problem. The problem statement is as follows: given two strings, find the length of the longest common subsequence present in both of them. Both the strings are in uppercase Latin alphabets. Let's consider this example: S1, str1 and str2. The output is 3. Let's see how. We'll consider the string str1 and str2. So S1 is given as ABCDGH, ABCDGH, and S2 equals AEDFHR, AEDFHR. Now, first, let's see what a sequence or a subsequence is. Now, a sequence or a subsequence is given a subset of characters taken from a container, but the order of the subset must remain the same. For example, S1 is a container of characters. Now, the subset of characters will be A, D, H, G, H. Now, the important point to notice is that the order of A, D, G, H given in the string remains the same in the subsequence as given in the string. Now, the longest common subsequence both present in the both string will be the sequence of characters present in both the strings and has the maximum length of all. The max of both the longest LCS present in both the string S1 and S2. Now let's take a brute force approach and example character by character. Considering character 1 and first character and first character in both the strings. Since A is present in both the characters, it will contribute +1 to the overall length of the longest sequence or the common sequence present in it. Let's not call it maximum, let's call it common. Now we will see C. We'll see B. B is not present, so it will have no contribution. C is not present in the second part, in the second string, so it will have no contribution. D. D is present here, so it will have a +1 contribution. Now, considering G, it will have no contribution since it's not present. H, it will have +1 contribution. Now, the string can also could have been given as A, B, C, D, G, H, and E, D, F, H, E, D, A, E, D, F, H, R, A. Now, if we are considering first character here, it will be the first match. Now, if we take the string, the string 2 terminates because we have to reach its end to find the because the first similar character present in the second string will be at A. So it will give a result of 1. Since we have been asked maximum, so we'll again consider B. We'll check it's not present. We'll consider C. It's not present. D is present, and again H. So the longest will be D and H. So the length will be 2. Hence we can say. Hence we see that we have to find the longest, not the first most common or not the first most common. We have to find the length. So we have to find all the possible subsequences and compare them if they are equal, and hence we have to return the maximum length. Now, let's consider an example of two strings S1 and S2, and let's see what will be our brute force approach to this solution, or the most basic approach. So we'll be taking the end of both these strings, and we'll check if both the characters are present. Then we'll add its contribution. Then we'll repeat the same task on the remaining string. This task is unknown, so I'm leaving this as empty, some task. Okay. Let's see what is this task. Now, this task is basically reducing the length of the first string. If both the end characters are equal, then it will be contributing to the common sequence, and we will be reducing the length. This task is basically reducing the length. Now again, since the length is reduced, here it can have again end characters and end characters. one end character in this string and one end character in this string. If they are equal, then this task will repeat itself. If they are not equal, then it will have two cases. Either we will have to remove character from end of the first string, or we'll have to remove character from the end of the second string. So if we are reducing character from the end of the first string, then it will break here, the end character will go away. If we are reducing the length of the second string, the first string will remain as it is, the length of the second string will decrease. Now let's understand why, how is this working, and what is its contribution to this picking and not picking situation. Let's consider string ABC. Okay, so we are picking element from position 1, then we will be picking or not picking element from position 2, then from position 3rd. If we are picking element from position 1, it will remain ABC, otherwise it will become BC. Element 1 is removed. Okay, if we are again picking element from position second position, that is from that is where is B, it will remain ABC. If we are not picking it, it will become AC. Again for this it will remain BC, and it will become C if we are not picking B. Now again, if we are not picking for position C, or for the position where is C, if we are again not picking it, it will become ABC. If we are picking it, I mean, and if we are not picking it, it will become AB. If we are again not picking it and picking it, if we are picking it, then it will remain AC, otherwise it will become C. It will become BC, or it will become C. It will become empty, or C. Sorry, it will become B, and it will become C. So here we can see that all the possible sequences, all the possible subsequences are generated by picking and not picking situation. Here we are doing the same thing. By picking and not picking in both the strings, we are creating the possible combination of all the sequences and comparing them all. So in this case, here it will generate, this decision making will generate the two possible solutions for both the sequences, and we will take maximum of this, because we have been asked the maximum, the longest common subsequence. It will generate a pair of all the possible sequences. We'll compare them and take the maximum value out of it. Okay, so this is basically how it works. Now let's see a recursive approach to this, and how to tackle this problem. So let's consider a function which will return our value, or the longest common sequence. So I'll call it solve, where this n is the length of the string 1, m is the length of the string 2, s1 is string 1, s1, and s2 is string 2. Now every recursion call has a base condition where it terminates, or where it needs to terminate. For example, in this situation where we were calling recursion, it must terminate at somewhere. It terminates when the end position is reached, or where we have considered all the possible elements, or all the possible values present in the container. Okay, so here all the possible value considered means either m becomes 0 or n becomes 0. So in that case, it will have no contribution, since the string is empty, so it will return 0. Now if m is 0, and if n is 0. Okay, now if both the end characters are same, means if s1 of n minus 1 equals s2 of m minus 1, then it will have a contribution of 1 plus that something function that we talked about. This task is reducing task, so this task will be LCS of returning some task. What is this task? Okay, this task is basically LCS, where we are reducing the length of both the strings. We are cutting the end segments, so we will reduce the length by 1, and again length by 1, and the s1 will pass and s2 will remain as it is. Now this is the only factor that we need to take care of to reduce the string. We don't actually have to break the value, or we can also do that, but that will take some extra amount of time to break the value. we can consider this method only, where we just maintain the index where we have to consider else. Now here is the decision making part. We are again doing the same thing, but we are breaking only one string from the end. See, if we are breaking string 1 from the end, n minus 1 will decrease, m will remain as it is, s1 and s2. Or again LCS, n will remain same, m minus 1, s1 and s2. Now since as we have already talked about it, we need to consider maximum of it, because we need the longest common subsequence. So we will take the maximum of both the outputs it will give. Okay, now this is the recursion part. It's the brute force approach. We need to memorize it, because as we can see that in decision, now since this is a brute force approach, let's see how to optimize it. Okay, since we are making decisions, so it will generate some decision tree. Due to decision making, some decisions may also be repeated due to the possible coming of input variations. So for example, if we are considering this tree and we have already calculated what decision making on this tree, what will it produce. Okay, so we will store this value somewhere in a variable. Okay, let's say x. Okay, we don't know that x. Now again, this tree comes again. Okay, this tree structure which has been repeated here, we know there is no need to traverse go through all those decision making, which can be further more complex. We can fetch this value again from here. Okay, so let's say we are storing, since there are two parameters we are handling, n or m. So decision making is happening on these two parameters. So the decision making is happening on both these parameters. So the structure of the tree will depend on these parameters. So we are considering a dp of size n plus 1 and m plus 1, which will be storing our value based on two parameters. Okay, n plus 1 and m plus, why we are taking a size extra than the given value. For example, we can also consider two strings which are empty. Okay, so in that will be taking a value, a space for 0, because we are taking no decision there, or the strings get emptied. Otherwise we are considering all the valued characters. So okay, now we have stored the value. Now we only need to do is to fetch it. Okay, so this is the optimal way of this is the optimization that we need to do on the recursion part. Let's see what variation comes in the code. So I have already written the code. Let's say I named it int solve. Okay, and I'm passing two variables, and s1 s2. If n equals 0, the base condition will be here, m equals 0, and then again we are calling the recursion part. If s1 of n minus 1, the end characters are equal, then we are again considering its contribution. Again here the recursion call will go. Else part, here we are taking maximum of both the returned values of LCS of decreasing string 1 and LCS of decreasing string 2. Here this is the decision making part. All we need to do is, while returning those values, we can store it in the DP segment. DP of n comma m equals this, and here again DP of n comma m equals this part. So if as I explained above, why we need to store it. Now where to fetch it? If we are considering a DP of n comma m, where we need to do the calculation, and if this value is not equal to some already present value, let's say the already present value in the matrix is -1, then that means that value has simply been stored. So we'll return simply DP of n m. That means there is no need to call this recursive. There is no need for these recursion calls. We can simply fetch it in constant time. So now let's see how the code works. I will be creating a function named solve, int solve, which will return the length of the longest common subsequence. I'll pass parameters n as length of the first string, m as length of the second string. I'll pass both the strings s1 and string s2. string, okay, spelling is correct. Now the base condition, if either of the length of the string becomes 0, okay, no means no further match can be done, so it will have a 0, it cannot contribute further, or it will have no contribution, so we'll return 0 in that case. Otherwise, now if we consider the end segments of both the strings s1 and s2, if they are equal, okay, so means it will have a plus 1 of contribution, so we'll return 1 plus some task that we talked about earlier. So it will return solve will do what? It will reduce both the length of the strings. So n minus 1 and n minus 1, so we are reducing the characters that has been matched from the end. Now we'll pass both the strings s1 s2, else we'll have to take a decision of either maximum of both the recursive calls or both the decisions that we made, considering either first string or the second string. So we'll return maximum of firstly we'll be reducing from the first string, so it will be solve n minus 1 means reducing from the first string, m will means the string second string remains as it is, s1 and s2. Now I will again pass solve, n means s1 remains as it is, m minus 1, and s1 and s2. So this is basically our recursion call. Now I'll store this value somewhere as solve n m s1 s2. I'll return this value x. So this x stores the length of the longest common subsequence. Now let's run this. As you can see, it passes our base cases. Now if we try to submit it, then it will obviously fail because it's not the optimized version of optimized code. See it fails the test case in the 10th test case itself. Now I'll be creating a DP matrix to solve the or to store the value. Now I'll be considering its length as size as 1002, because the length of the given maximum length of the given possible string in this question is 10 to the power 3, and as we have to consider n plus 1 means 10, we can also take 10,001 1001. It will also work, but I'm taking 1002 because I always take one more or 2-3 more for the sake of not making any mistake or any possible error. Now I'll be storing this value. Now first I'll initialize this DP with -1 values. -1 is the possible value that cannot occur. If a possible value 0 can occur, because if one string gets empty, then it will have 0 contribution. We cannot take that value in the string because it will be a valid value that possible case of sequences will can contribute or can have. But -1 is as an invalid value that cannot be processed and stored. So I'll fill the matrix with -1 values. So I can either iterate or use a meme set, which is an inbuilt function. Here is the syntax of it: -1 DP. I'll pass the name, the value I have to fill with, and I will pass the size of the DP, size of the matrix. Now the DP is now filled, the matrix is now filled with -1. Now since we have filled our DP, now at some point of time, if we are calling our DP on an m variable, if it is not equal to -1, means for some variable of inputs n m, -1 has already been stored, which now in this case we can return the stored value. There is no need to go further down the code and execute this if else statements or the recursion part, hence it saves time. Now here it returns the value stored here, stored in the DP above. Now how to store this value? Now since we have computed this here value here, before returning it itself, we'll store it in the DP. there will be only slight change from the recursion code to the DP program, from the DP code to optimize it. Once you know the recursion part and if you know the decision making part, you can easily optimize it. Now now as we can see, we have already stored. Now this memoization is complete, plus that returning part is also complete. Now if we again compile and run to see if there is no possible error. See, we are still getting time limit exceeded, and I have an explanation to this why. Now we are passing the string as reference. Now in every function call, all the recursion calls we are making, we are creating a value. We are creating a copy of the string s1 and s2. The size of the string s1 and s2 can be large, and hence making a copy can add an extra overhead. Now, if we pass this by reference, means we are not creating the copy of the those strings. We are only passing the address of the address of both the strings, or we are passing the reference to it. Now if I run this code again, we can see that all the test cases has been passed. So yeah, that's all from my side. I hope this explanation makes sense. Thank you.